Okay, so the next lesson in physics that we're going to talk about is acceleration. So, acceleration, just kind of as an intro to it, take a look at that question at the top. So it says, why does it hurt more if you fall from a higher height? So if you were to fall from, the top of a desk or something like that, it's going to hurt a lot less than if you fall from the top of a building or something like that. So let's take a look at this moose. If he's falling down, it's going to hurt a lot more if he falls from a higher height. Why is this? Because of acceleration. In this case, it would be because of the acceleration due to gravity. So gravity pulls something towards the surface of the earth. So as it falls, it's speeding up. And that's what acceleration means. The velocity is changing. So underneath that, you're going to see a definition for the word acceleration. Very, very important. So acceleration is a measure of a change in velocity over or during a change in time. And from that definition, we get a formula. So at the bottom here, you see the formula. Acceleration is a change in velocity, note the vector here, over a change in time. We could also write that as velocity 2 minus velocity 1 over t2 minus t1 like this. Or velocity final minus velocity initial. So there's your formula for acceleration. When we're solving things in physics, we want to understand them mathematically, but also kind of the concept of it. So acceleration, if you think about it, if you're driving your car, and let's say you're stopped at a stoplight and you're going to accelerate, all it means is you're speeding up. So that would be positive acceleration. We also can have negative acceleration, which we'll talk about in a little bit. Okay, next screen here, positive and negative acceleration. At the top, think about it. If an object has a negative acceleration, what does that mean? So if I was to tell you that something was, accelerating in a negatively, all that really means is a fancy way of saying in physics that something's slowing down. Another way of thinking about that in the box here is that acceleration is in the opposite direction as the velocity. So let's take a look at the bottom, a couple pictures there that will hopefully help you understand these. So these are miles per hour, which is a different way of measuring instead of kilometers per hour, but really it's just a way of measuring speed. So the first truck shows you positive acceleration. I have a truck or vehicle here that's traveling at 50 miles per hour. Its initial speed, so we'll call that its VI, is 50 kilometers per hour, and its VF is 70. That's positive acceleration because it is speeding up. It went from 50 to 70. 70 is greater, so it's positive. This one, for example, though, is the opposite. I have an initial velocity of 50, but a final velocity of 30. 30 is smaller than 50, so this is what we call negative acceleration. So positive acceleration means it's speeding up. Negative acceleration means slowing down. So this can get a little bit tricky. Just on the left here, it says, because acceleration is a vector quantity, positive and negative signs can also tell me the direction. So I'll show you some examples with that because I know it can be a little bit tricky here. Okay, so take a look at these examples here. I'll explain what those arrows mean. Those arrows are just vectors. I want to go through just one more example to help you hopefully understand what this positive and negative acceleration means. So what these vectors are showing you, take a look at the first example. What this is saying is I have an initial velocity that would be going to the right. Right here. I have initial velocity to the right. I have a final velocity that is also to the right, but the final is greater than the initial. So a VF, a longer arrow, means it's bigger. Acceleration in this case is also to the right. So I want you to think about what would happen to those objects, to that object in that case. So its final velocity is bigger than its initial velocity, and its acceleration is also to the right. So if this was, you driving a car or something like that, what would happen? So I can click on this box, we'll move it. This would mean it's speeding up, or it's positive acceleration forwards. So please make sure you're writing these examples down, they're really important. Now, pause the video here. I want you to try the other three on your own before I give you the answers. So this second one says I have an initial velocity to the right, a final velocity to the right, but an acceleration to the left. Also important is that final velocity arrow is smaller than the initial velocity arrow. So what would happen to that object in that case? So pause the video right here, and then I'll reveal the answers for you in a second. Okay, so let's go through these really quickly. First one, or I guess I gave you the first one, this would be the second one. If I have a final velocity that's smaller, so the velocity was decreasing, that means it's slowing down, which we also call a negative acceleration. This one on the bottom left, I have a final or initial velocity to the right, a final velocity to the left, and a negative acceleration. This is also called negative acceleration, but the object, another important thing is happening. Because the initial velocity is to the right and the final velocity is to the left, that means the object turned around, so it changed directions. Last one over here, we can get rid of that. I have an initial velocity to the left, a final velocity to the left, and an acceleration to the right. The object is slowing down because this arrow is smaller than this arrow, or sorry, bigger. The final velocity is smaller, so it's slowing down. It's positive acceleration because it's going backwards. So hopefully that'll kind of help you understand the difference between the two. Okay, now that we've taken a look at the definition and kind of some examples of what the difference is between positive and negative acceleration, let's do some practice problems. Now that we're in acceleration, the questions are going to start to get just a little bit more complicated. So what I'm going to do when I start this question is sort my information by writing down my given. So what is this question giving me? So I'm going to start at the beginning of the question, start reading it through, and write everything down. So I'm starting here. A car has an initial velocity of 4.00 meters per second. So its initial velocity, I'm going to call that VI, is 4.00 meters per second. The car speeds up to 26.0 meters per second, so that's my final velocity. VF is 26.0 meters per second. Instead of VI and VF, I could also call this V1 and V2. So I could also put V1 and this would be V2. It doesn't really matter. I keep reading. Next thing I see is 4.20 seconds. So that's a change in time of 4.20 seconds. Then it says, what is the acceleration? So at the bottom of my givens, I will put acceleration equals question mark, meaning I'm not sure what that is. So now that I have my givens sorted like that, it makes it a little bit easier for me to pick my formula and kind of figure out where everything goes. So I know my formula that I'm working with today with acceleration is change in v over change in t. Acceleration is a vector and velocity is a vector, so we'll put the arrows over top. So I have acceleration is a change in velocity over change in time. But I have two velocities, so a change in velocity is just exactly what it means. What was my final velocity compared to my initial? So I'm going to rewrite the formula as final velocity minus initial velocity divided by a change in time. So that final velocity and initial must have vectors over it because they are a vector. So now we can plug in our numbers here. Final velocity we know is 26.0 meters per second. I have an initial velocity of 4.00 meters per second. So all I'm doing is taking my givens, plugging them in where they match the formula. Divide that by a change in time of 4.20 seconds. So on my calculator, order of operations very important. I'm going to take 26, subtract 4, so that's 22. Then I'll take that answer and divide it by my 4.2 seconds. So that gives me an answer on my calculator. 22 divided by 4.2 is going to give me an answer of 5.23809, and this keeps going. So a lot of numbers there. Acceleration unit here, we haven't talked about this yet. The unit for acceleration is a meter per second squared. And that just comes from my equation. I have a meter per second on the top, a second on the bottom. So it's kind of like saying a meter per second, but we write that as a meter per second squared. So that's my units. Here, though, I need to make sure my answer is rounded to the proper number of significant digits. So I don't want to keep my answer with all those numbers that just go on for a really long time. We want to round that. So I can only keep the first three. So I can keep the 5, the 2, and the 3. But I have to decide, is this 3 going to stay as a 3 or should it round up to a 4? In this case, the number beside it is an 8, so it will round up. So my answer will be 5.24 meters per second squared. So final answer, I have 3 significant digits, I have a unit, I've shown all my work, this question is good. Okay, next one. This question pretty similar to the one that we just did, so I'm going to give you some time to do it. Pause the video here, try this question on your own. When you've got it solved, press play and the answer will show up for you so you can check to see if you did it properly. I want to see the 3 steps, your formula, your work, the final answer. Okay, let's try another one. This one says, Greg falls out of a high tree. If he falls for 3.00 seconds, what will be his change in velocity? So this time, I'm not looking for acceleration, I'm looking for change in velocity. So a really important concept here, anything that falls to the surface of the earth is always going to fall at the exact same acceleration, and that is 9.81 meters per second squared. So if you see anything that's falling, always we can assume that acceleration will be 9.81. So this time, if I write down my givens, I know acceleration is 9.81. Acceleration is always measured in a meter per second squared. I know the change in time is 3.00 seconds. So you can write that down. And I want to know what is his change in velocity. So we'll put a question mark there. So we'll start with the formula in its original version. A is change in V over change in T. Arrows on it. I'm going to rearrange this formula for velocity by getting rid of the time and moving it to the other side. So it's on the bottom, which means I'm going to multiply it on the top of the other side. So to get rid of the opposite of dividing by time, or to get rid of it, is multiplying by time. So my formula for change in velocity will be acceleration multiplied by a change in time. Time is scalar, so that's why it doesn't have to have the arrow on top of it. The direction, time can't have a direction, so it doesn't matter. Now I can plug in my values. Acceleration is 9.81 meters per second squared. Change in time of 3.00 seconds. Grab my calculator. 9.81 times 3.00 gives me an answer of 29.43 on my calculator. This is velocity, so it's measured in meters per second. So I'm going to write down the answer. That's what shows up on my calculator, but I'm going to round that to the proper number of significant digits. So 9.81 has 3, 3.00 has 3, which means I can only keep 3 of these. So I need to decide, is that 4 going to stay as a 4 or get rounded up? In this case, it'll stay, so I can say 29.4 meters per second. Because this asks me for velocity, I need a direction. If you're falling, we can say, obviously, then you're moving down. So my final answer would be 29.4 meters per second down. Okay, one more. Similar to the one we just did. A cat falls from a window ledge. Too bad. If the cat falls for 2.50 seconds, what will be the cat's final velocity when it strikes the ground? Same idea. I want you to pause this. This is an individual problem, so try this on your own. Write the question down, solve it, and then I will give you the answer here on the screen.